All right, good morning, everybody. It's all about communication. So, if you know you're going to be late because of a specific reason, again, you can always watch the videos later, but if you communicate with me, I can mentally have it prepared and take care of it in advance. But I appreciate you guys respecting my rules so that we could get rolling on time. Okay. All right. Let's do something that's a little applicable. We're going to go down the rabbit hole a little more. This is on page 30 of your notes, of your materials I gave you. Let's look at our wrist. Let's see which one this is. This is a left wrist, and we're going to talk about verbiage. We're going to talk about verbiage. So what is the wrist? The wrist is a joint. It's an articulation of bone. It's a diarthrodial, meaning that it has significant movement. Remember the three different types of joints: the articulations that don't move at all, the synarthrodials, your sutures in your skull, and those kind of things. Your ilium pubis, meant to fuse and not move, like a weld, like your body welds it shut once you stop growing. Then you have amphi, little bit of motion, little bit of play. In your vertebra, a little bit of play, your pubic symphysis, a little bit of play, metacarpals, a little bit of play. Then you get to the major ones, the big plays, the ones that have significant motion, okay? So the things that I need you to do on your own is to remember from anatomy lab, like, okay, what bones make up the wrist? We have our radius, our ulna. I'm not going into detail with triquetrum, trapezoid, this is some corporal bones, right? Some corporal bones articulate with the radius and the ulna. And the motion is going to be here about a bilateral axis or sagittal plane. And eventually, when we get into more detail, I'm going to talk to you about frontal plane wrist motion, about an anterior posterior axis. For this class, what I'd like you to do is follow me through communication of position and motion through a full range of motion. It gets a little tricky, but the more we practice, the less tricky it gets and the easier it gets, okay? So we'll start from anatomical position, all right? Where is my wrist at? Anatomical, great. Let's go down first. Flexion from anatomical. That's important because if you just say wrist flexion, well, what if you started up here? I could have wrist flexion in any change of position, but if I say wrist flexion from this, then you know exactly what we're talking about, right? And then to communicate miles, I went 30 miles from Bro Bridge. Well, that's angles, that's degrees. So you got goniometer, you'd say 35 degrees from, that's how they do this. That the angles with the goniometer is our miles, the distance traveled angle. So flexion from anatomical. I'm in a flexed position here. Extension to anatomical, back to where you came from. Extension from anatomical. And then here's the tricky one. Flexion to anatomical, flexion from, extension to, extension from, flexion to, flexion from, extension to, extension from. Does that make sense? A couple of reasons this is going to be important for you guys in clinical settings and therapy school is when you're doing ranges of motion. Like, I think I have an example up here why it's important to talk this verbiage. You're doing range of motion and certain joints have certain, ranges. But you have to know, where am I starting from? And so for instance, if you were going to check someone's hip flexion, you would start, goniometer here, nice and straight from anatomical, and you'd measure how much flexion they have. But if you're going to do extension, anatomical position, leg straight, how much extension do you have? So we have to have a reference of where we're going to start in order to measure. Like if someone's like, I have a lot of extension, and they start here, and they're like, look at all that extension. So where you start is important. Okay. In addition, one of the things that I'm teaching you that I want to emphasize that you may not realize is when you're doing range of motion or checking someone's motion, those illusions are going to give you false information sometimes. Give an example. Let's say our hip is supposed to have 15 to 20 degrees of hip extension. Well, if they're bringing their leg back, they don't know anything about human movement. You say, okay, bring your leg back so I can check your extension. And they do something like this. Like, whoa, that's a lot of extension, right? Or here's a frontal plane example. Try to get your arm over your head, and let's say they do something like this, and their hand goes over their head, but their shoulder only got to here. Does that make sense? So it's another reason why we kind of have to see these illusions. Let's do a practice. Keeping it on the wrist. Okay? Remember, follow the fingers. Fingerprints will lead you to flexion. Fingernails will lead you to extension because the wrist doesn't twist. So flexion will always follow the fingerprints. Extension will always follow the fingernails. Here's a very applicable question that I'm going to ask on the test that I just want to see how you're thinking right now. Remember, it's okay to miss it when it doesn't cost you anything. I'd like to know the wrist position at the top picture. I'm going to give you like 3 questions. Write it down, memorize it, however you want to practice. What's the wrist position, bless you, at the top? So it's either flexed, extended, or anatomical. What's the wrist position at the bottom? It's either flexed, extended, or anatomical. Now, again, there's nuance. I could be flexed 15 degrees. I could be flexed 90 degrees. That's the nuance. Just because I'm east of Lafayette doesn't mean I'm in the same location as someone else who's east of Lafayette. They might be further. Position of the wrist at the top, position of the wrist at the bottom. And then the last 2 questions is talk to me about motion change. When I go from top to bottom and bottom to top at the wrist, we are just having a wrist conversation. Just a wrist conversation. I'm not disrespecting elbow and shoulder. I'm just not talking about it right now. We can after, but I'm respecting us analyzing motion joint by joint. Let's have a wrist conversation. Position at the top, position at the bottom. Motion from top to bottom, motion from bottom to top. Go, give it some thought. As always, feel free to discuss with your neighbor. This is the best time, in my opinion, for knowledge, is when you could say, hey, what are you thinking? This is what I'm thinking. If you're thinking the same thing, great. If not, that's when you could try to plead your case. Someone got really close for the football score Friday. Let's see. I ought to give it some thought. See if I can find Landon? Is Landon here? Dude, you were close, man. 42-28 Eagles. Yeah. Well, someone put you down. So unless we have 2 Landon. I appreciate the honesty. I'd have been like, yeah, that's me. All right, you guys. Position of the wrist at the top, flexed, extended, or anatomical? Extended. Now, how much extended? We could kind of eyeball. You know, it's not quite 90, but it's getting there. You know, like a right angle, right? Not quite 90, but it's not flat. So we're extended. The next picture on the bottom, what's the position? still extended. But the nuance is I'm less extended. I'm closer to anatomical at the bottom than I am at the top. True? That's like saying I'm east of Lafayette, I'm in Baton Rouge. But now when I check, I'm still east of Lafayette, but I'm in Breaux Bridge. Well, the only way I can get closer to home but still be east is traveling west. Yes? So the motion from top to bottom was bilateral wrist flexion, even though I'm still extended. That's okay, and it should make common sense. I'm less extended on the bottom one, and I'm more extended on the top. So the only way to go from being more extended to less extended is to have flexion. I'm getting closer to fetal. The person doing the push-up is actually closer to fetal on the bottom than he is at the top. I'm not saying he is in fetal, but he got closer. Thus why he had flexion. Does everybody understand? Top, bottom to top. He's extended at the bottom. He's more extended at the top. The only way to go from being a little bit extended to more extended is to have extension. You see the nuance? For a shoulder, I can be flexed. I can still be flexed, but I had to have extension to get less flexed. That make sense? Jim's tricky. You good? Still. Okay. Thank you for letting me. That's right. It's all about communication. All right. So let's move on to, first of all, any questions, clarifications? Am I communicating this well? Okay. Let's go on to the elbow. Okay. Let's go on to the elbow right here. Now, some joints.
Is that ever so versions question should that one? Is that going to be someone who's like someone next question?
Oh yeah.
Cool. So basically, you may show or after you analyze this.
I can. Yeah. Again, so what I'm hesitant to do always is give you the test, because then that's not testing your analytics. But I'm going to say, all right, guys, we're going to have a math test, and it's just an analogy. We're going to have a math test, and we're going to do a lot of practice problems. But none of those exact problems are going to be on your test. But does it matter? If you know how to add, subtract, then you're like, oh, I know. It doesn't matter the problem he gives me. I know how to figure it out, right? So the wrist joint is like Lafayette in the middle of the interstate, meaning I could travel east or I could travel west from anatomical. Not every joint is like that. Not every joint allows you to have motion in both directions. The elbow is one of them. The elbow, anatomical position, you're all the way at the end of its interstate. You're all the way at the end of the road. It's like from coast to coast, like an Interstate 10 that goes from Florida to California. You're all the way at the end of the road. If you traveled any further, you would have hyper, and that would be a bad day. Okay? So from here, if you're all the way at the end of the road for the elbow, if you're in an extended position, meaning you're east, there's nothing further east. Remember, we can't say Lafayette is east or west, because to one town we're east and to another town we're west, right? But when you're all the way at the end of the road, you can say, I'm east, because there's nothing else in reference to it. So for the elbow, anatomical position is synonymous with being in an extended position. They're synonymous, interchangeable. So any motion Normal range of motion has to be into fetal. Flexion. Extension to, flexion from. Extension to, flexion from. And what happens if you go past? That's what hyper. Excessive, beyond normal range of motion. So let's apply our elbow verbiage to our example. Top to bottom. Bilateral elbow flexion from anatomical, right? Because at the top, we're in anatomical. Flexion from on the way down, extension to all the way up. Elbow should be pretty easy. All right. Now let's go to shoulder. Now, we're going to make some assumptions because the shoulder is a three-dimensional Etch-a-Sketch board. So let's say elbows are close and most of the motion is going to be sagittal, or whatever component of the motion is sagittal, that's what we care about. Okay. So in other words, even if he's going out at an angle, we're going to talk about the frontal plane stuff when we go into the shoulder in more detail. All I want is the sagittal component of the shoulder because that's what you're accountable for in your test, right? So we did the wrist. I think we handled that pretty well. We did the elbow. I think we handled that pretty well. Now let's do the shoulder, which is a little bit different. Motion is just change in position. Where am I at? Where did I go? How did I have to move to get there? Position of the shoulder at the top, sagittal plane of the shoulder, position of the shoulder at the bottom. How did it have to move to get there? Then go back up, position of the shoulder at the bottom, position of the shoulder at the top. How did the shoulder have to move to get there? Ready? Go. Give it some thought. All right, we're good. Top to bottom, did the shoulders have flexion or extension or no change? Extension, bilateral shoulder extension. Any questions, clarifications on that? Bottom to top, bilateral shoulder flexion. Any questions, clarifications on that? Now let's go down the rabbit hole a little bit. What if I would have given you, now again, it's all math. Change in position, motion, that's all physics, it's all math. What if I'd have asked it this way? What if I'd have said, person's doing push-ups, right? Just going back and forth, just doing repetition. So he'll go down, come up, he'll go down, he'll come up, he'll go down, he'll come up. What if I asked you to tell me what shoulder motion is happening when you observe elbow extension? Like, in other words, I give you a variable. I say during the push-up, what does the shoulder do when the elbow is extending? Does that make sense? So you say, okay, well, when I see elbow extension, will that be top to bottom or bottom to top? Elbow extension is going to be from bottom to top, right? So then you just say, okay, what's the shoulder doing from bottom to top? That makes sense? It's like I'm giving you something to see, and again, what I'm testing, I'm not meaning to be tricky. I'm checking your understanding. Do you know what elbow extension is? Because if you do, it shouldn't be a problem figuring out, oh, he's asking me to go from bottom to top and tell me what the shoulders do. Make sense? Lindsay said these practices, you guys like that. Is that true? All right, let's try some more. Open-ended question. What can you tell me about the elbows in this exercise? Definitively, no doubt, no question. You putting all your chips in. What do we know beyond a shadow of a doubt? Let's just, for the sake of ease, let's just look at the arm that he has the dumbbell in. What do we know? Was that? His elbow is flexed. That's all we know. Can we say flexion? Does that make sense? We can't say flexion for a few reasons. I don't know if he's going up or coming down. And most likely, he's just holding that position for the picture, right? There's no motion. He can be flexed, but not necessarily be flexing. His position does not have to be synonymous with his motion. Yes? If he starts to lower the dumbbell down, his position is still flexed, but the motion would be extension. He would just be less and less and less flexed as he gets closer and closer and closer to anatomical. Right? If the dumbbell goes up, still flexed, you would have flexion. So a full range of motion would be flexion from anatomical, extension to anatomical, flexion from, extension to. And that's how we would verbalize it. Any questions, clarifications as we practice this verbiage? Let's see if I can get another good one here. All right. Let's go position of the right wrist. For those of you that have been practicing, studying, that's all right. You know what I'm asking. Some of you who are kind of, that's all right. We all, it's all about riding the bike. Some of you may be like, well, wait, which wrist is the right wrist? I taught you that. Is it your right or his right? His right. Absolutely. It's the person you're analyzing. You can become that person. Like if you wanted to recreate it, you could become that person so that the right is your right. But when you're working with people, it's their body, it's their bones, it's their joints, it's their muscles, it's their movement patterns. You're working with them. And you have to remember it's a mirror effect to you. So if you're facing someone and say shuffle to your right, y'all are going in two different directions. Amputate right leg. Keep using that example. Why? Because it's happened. Bless you. Okay? Right wrist. What's the most obvious thing? All sagittal plane. Is he flexed or extended or an anatomical? Extended. Can we say he's flexing or extending? Not from that one picture. Does that make sense? Left elbow flexed, right elbow flexed, right shoulder flexed, left shoulder flexed. positions of knees, hips, shoulders, elbows, wrists. Reminds me of that song when I was a kid. Head, shoulders, knees and toes, knees and toes. Position, knee, hip, shoulder, elbow, wrist. So the miles, the analogy of miles to linear, right? 30 miles east of Lafayette, 20 miles west of Lafayette is angles. That's what we use goniometers. So you can say, I'm not going to ask this on the test. The test is just about motion, position. Are you or are you not? But eventually, when you guys go into grad school, you're going to learn about angles and goniometry. So like his knees are flexed, right? And then you could say, well, how flexed? Because that's flexed 80 degrees, 90 degrees, 60 degrees. His hips are flexed. True? His shoulders are flexed. Good. Elbows are flexed. Good. What about the wrist? Anatomical. No significant deviation. Does that make sense? Remember, I'm not going to ask you things like this. It's going to be obvious. Is there any proof that there's motion happening here? None. We got nothing. So I'm warning you. Maybe this is one of the good things about coming to class in person. Although people that watch the videos some of them still do very well. If all I do is show you this picture, guys, I'm playing cards. I'm playing poker with my cards out. I'm telling you what I'm going to ask you. And I'm telling you why some students are going to miss it. I'm going to give you a picture like this, and I'm going to say, what's happening at the elbows? And the answer choices is going to be flexed, extended, anatomical, flexion, extension. And some students are going to, it's tricky. And I'm like, it's not tricky if you just understand what I'm trying to teach you, that in order to have motion, we have to have information. We have to have information. We have to have a change in position. You have no idea. What if he's going down? We don't know. What if he's just holding that position? There's no motion there at all. It's my way of testing you and making us understand the difference between position and motion, which is very important. Okay. All right, how about one of these? Okay, let's do hips and knees. With a leg press, let's say his feet start to go away. Remember, ankle is not on your first test because the ankle has two different types of flexion, because there's two different ways you can get in the fetal. Feet off the ground fetal and feet on the ground fetal. So all I'm asking you on the first test are things that flex and extend. Okay? So let's analyze knees and hips. Feet get pushed away. What would the knees and the hips be doing? Extension, bilateral knee extension, bilateral hip extension, right? What's the position here? If I just gave you the picture, knees are flexed and hips are flexed. Do you see how I had to give you more information? The feet start moving away. I had to give you more information. information to give context to the movement or before and after. Another point that I want to teach through repetition, anatomical position isn't all or nothing. It's not the whole body or nothing. Anatomical position is per joint. My elbow can be an anatomical, even though my shoulder isn't. My wrist can be an anatomical, even though my knee isn't. Does that make sense? My left hip can be in its anatomical, even though my right hip isn't. It's all local relative to each joint. All right, what about this one? Here we have some context and before and after. So let's go left to right. Left to right, bilateral, shoulder, extension. Good. So right to left, bilateral shoulder flexion. Cool. From this position, she lowers the dumbbells down. Talk to me about shoulder and elbow. From here, she lowers the dumbbell down. What would happen at her? First of all, you tell me, would it be her right or her left? Right, good. It's her right. Her right shoulder, her right elbow. She lowers it down. Right shoulder would have what motion? Flexion, good. Right elbow, extension, good. We'll get to scapula, we'll get to all that other stuff. We gotta learn the verbiage first. What's the position of her left shoulder? It's what? Flex, good, absolutely. What about her right hip? Flex, yeah, left hip also flex. Which knee is flexed, her right or her left? Good. What about her left wrist? Extended, good. You see why we don't say her left wrist is extension, right? It might have had extension to get there, but it's parked. It's not moving, it's not going anywhere. Flexion, extension, abduction, internal rotation, those are motion things, change in position. Flexed, extended, internally rotated, position verb. All right, let's do this one. What do you think? Team trunk or team hips? Don't answer right away. Give it some thought. Most of that motion, do you think that came from trunk or hips? See if you can use some clues. Webcam, yay. Ken makes class 10. I'm gonna give you a hint. There's some illusion stuff, but this is actually a continuation of our first question with the ribs. Where is my hip? Don't even care about the trunk right now. Do like an elimination, process of elimination. What position is the hips at the top? Answer that and say, okay, well, it might be this. And then at the bottom say, well, Did that position change? Am I more? Am I less? Am I the same? Because that's really where you get your answer. Hips or trunk? Hips. Now it's my job to prove it to you. Oh, Lord, I'm getting old. This is where we need an ice machine. All right, straight up. Do you agree with me that at the bottom picture, her hips look to be about 90 degrees with her trunk shape? Right? At the top picture, it doesn't look like it's 90 degrees with the trunk, right? So in essence, Kelly Clarkson. What happened is she's here, her hips are flexed, but they're not flexed in 90 degrees. And then she gets to here, now her hips are flexed at 90 degrees. So how can that happen? Hip flexion. She's more flexed at the bottom than at the top. That means we had to have hip flexion to get there. If all she did was move her trunk, she would be doing crunches and her hips wouldn't change position. Does that make sense? But the fact that the hips literally got more in the fetal from top to bottom means she had to have hip flexion. Here's another way to look at it. If I wanted to tie my shoes, pretend, like, all right, got to go down there and tie my shoes. All right, trunk, what you got? Like, your trunk doesn't have much, guys. And the reason it doesn't have much is because it's kind of protecting some valuable plumbing. Trunk doesn't want to do this. It's a bad day for plumbing. It'll give you some, but it's not going to give you a lot. Trump gets credit for a lot. So let's talk about the illusions. One of the reasons this is a tough question is because the hips aren't moving traditionally. You know, maybe we were introduced to hip motion where the femur always moves about the socket, right? The acetabulum. But in this case, what's happening is the acetabulum is moving about the femurs. Just like this. You have a fixed ball and movable socket. That example is just a different form of here to here is the same as from there to there. It's just I'm laying down while doing it. Does that make sense? Yeah? All right. Let's do a couple. Are y'all enjoying the practice? How about this? Let's do hips, A to B. And also give me, just practice. What's the position at A of the hips? What's the position at B for the hips? And then that change is how you have to move. Change is given. In junior high algebra, if you had a 3-variable equation and you knew A and you knew B, guess what? You know C. That's what I'm showing you here. If you know the position of A and you know the position of B, then you can solve for C. Okay, what did the hips have from A to B? Bilateral hip extension, absolutely. Because that's the only way to go from being flexed to going anatomical. You have to have extension. Would I ask you about the knees? Absolutely not. There's not enough change there. Look, that looks pretty right angle to me, and that looks pretty right angle to me. I wouldn't even bother. I'm not going to ask you things that just move a little bit. open-ended. This is the crescendo of class today. You are the experts in kinesiology. You tell me what had significant motion going from left to right. Side joint motion. Good examples of all the illusions. And then there's one in particular that's extra sneaky. And we'll see if you caught on to it. It's like Adam Sandler movie, Mr. Deeds. Oh, that's before your time. You underestimated my sneakiness. I am very sneaky. Remember, guys, if you're awake, you can be studying this stuff. If you're working, you can be studying this stuff. If you're cooking, you could be studying this stuff. If you're lifting, you could be studying this stuff. That's how I used to do it. I would just review my planes and axes, references. I open the door. That would be in the transverse plane of the room. And I'd be, well, can I see it in my sagittal? Yeah, if I tilt my head, I can see it in my sagittal. There's lots of ways. And I'm here to clarify, if you're studying, guys, I have 24-hour office hour, virtual office hours, 24 hours. If I'm awake, I'm old, but if I'm awake, because my thought process is if you have a question, I don't want you to have to wait 2 days to get it answered. You know, if it's a quick clarification, let's do it so that you could keep studying. All right. Let's first go yes or no. Was there motion? Right hip. Yes or no? Okay, awkward silence is not an answer choice. Her right hip. Yes or no for significant motion? No. Stay straight. It looked like it's moving, but it's not. Left hip, yes or no? Great. If yes, how? Flexion. Good. What's the new position of the left hip on the right? Flexed. The position is flexed. The motion to go from anatomical to being flexed is flexion. You see the difference? Flexed is where you at. Flexion is how are you going to feet. Shoulders, bilateral shoulders from left to right. Was there motion? Yes or no? Yes. Good. If the answer is yes, what was the motion? Flexion, bilateral shoulder flexion. That's one of those illusions. It looks like it's not moving, but it is. Follow me here, guys. If the shoulders did not move, if the shoulders stayed by her side, you would have seen this. Does that make sense? The shoulders had to flex. Anybody catch the extra super sneaky one? Cervical, outstanding. What did the cervical do? Extension. How do I know? Because if her cervical, you see how her head is still level? If her cervical didn't move, she would be looking at the ground. Her cervical had to have extension to keep her eyes level. Good catch. Do we feel more comfortable? We feel more confident? Guys, I'm giving you a heads up. This first class is all about introductory to verbiage. Planes and axes. Global, the room's sagittal, the room's frontal, the room's transverse. But when we're talking about our joint motion, it's our sagittal. our sagittal, our sagittal. My elbow can flex in all three of the room's planes, but it can only flex and extend in its sagittal plane. So on the test, I don't want you to think that this is any different than this. It's the same motion from, if I interviewed the elbow's like, dude, that's all he does. I just keep going to fetal and out fetal. Make sense? This is the exact same as if I was here to the cervical. It's doing the same thing. Any questions? Clarifications? All right, guys.